All right, so let's dive into this world of drone swarms.
Yeah.
The research papers you gave me are fascinating,
Oh, good.
especially how these swarms operate like networked control
That's
systems.
right.
It's amazing.
Yeah.
We're going to uncover how to coordinate all these flying robots,
Right.
the magic behind the networking,
Right.
the computational systems, and what makes them so adaptable and powerful.
It's really where robotics and network systems are kind of colliding and
Yeah,
pushing each other forward.
exactly. We're also going to unpack some real-world applications too,
Right.
from search and rescue to
Yeah.
target tracking.
Sure.
But before we get ahead of ourselves, let's break down the basics.
Yeah, let's start with the basics.
What exactly is a drone swarm?
Yeah.
And why are they creating such a buzz these days?
Well, a drone swarm is basically a collection of these unmanned aerial vehicles, or UAVs,
Right.
all working together in a coordinated way.
Okay.
You can think of it almost like a flock of birds
Yeah.
or a school of fish, but with artificial intelligence added to the mix.
We already see individual drones doing some pretty impressive things like photography,
Yeah,
package delivery,
Mhm.
you name it.
for sure.
What makes a swarm so much more powerful than just a single drone?
That's a great question.
Yeah.
That's where the real magic happens.
Okay.
So imagine a search and rescue mission
Yeah.
after an earthquake.
Okay.
A single drone might miss crucial details
Right.
because of its limited perspective.
Yeah.
But a swarm with its multiple viewpoints can quickly cover a vast area
Right.
and pinpoint the location of survivors,
Okay.
much faster, potentially saving lives.
Wow.
This is possible because of something we call emergent behaviors,
Emergent behaviors.
where simple local interactions between the drones
Okay.
lead to complex, coordinated actions.
So it's like having 100 sets of eyes instead of just one,
Exactly.
all working together.
That's a great way to put it.
Yeah.
And that's why we're seeing drone swarms being utilized in everything from military operations,
Mhm.
surveillance, to package delivery,
Yeah.
even environmental monitoring.
Wow.
The potential is truly vast.
These research papers delve into how drone swarms act as
Yeah.
networked control systems, or NCSs.
Mm-hmm.
Can you shed some light on that connection for us?
Absolutely. So think of an NCS
Okay.
as a system where control is distributed across a communication network.
Right.
It's not centralized in one spot.
Okay.
Now picture a drone swarm.
Yeah.
Each drone is constantly communicating, exchanging data-making decisions collectively.
Wow.
That's what makes them so adaptable and resilient.
So the drones aren't just blindly following orders.
Exactly.
They're actually part of a decision-making process.
They're sharing information, reacting to each other,
Yeah.
and adjusting their actions based on what's happening around them.
That's fascinating.
But as you can imagine, coordinating a drone swarm like an NCS is incredibly complex.
I can imagine.
We have fluctuating wireless conditions,
Right.
environmental obstacles, and the inherent challenge of real-time distributed decision-making.
Yeah, it's got to be pretty tough.
Yeah,
So how do you even begin to deploy these swarms effectively?
that's a great question. So there are two primary strategies.
Okay.
Non-interactive and interactive deployments.
Okay.
Non-interactive is more straightforward.
Got it.
The drones might operate independently,
Sure.
perhaps with a central ground control for simple tasks.
Right.
Imagine a fleet of delivery drones,
Okay.
each following its own route,
Yeah.
but reporting back to a central hub.
That makes sense. What about interactive deployments?
Yeah.
I imagine that's where things get really interesting.
You're right, interactive deployments are where we see the true power of swarm intelligence.
Okay.
Here, the drones are in constant communication, coordinating with each other.
Wow.
This allows for much more complex behaviors
Right.
and a higher level of autonomy.
I-
Think of a swarm exploring a collapsed building after a disaster.
Oh.
They're sharing data about structural integrity, potential hazards, and the location of survivors,
All in real time.
all in real time, allowing them to adapt and make better decisions than any single drone could.
Yeah, it's powerful.
Yeah.
Okay, so we have our deployment strategies,
Mm-hmm.
but how do the networking and computational systems actually work within these swarms?
Right.
What's happening behind the scenes?
Well, the networking system is the communication backbone of the swarm.
Okay.
It establishes the links between the drones,
Right.
enabling them to share data and coordinate their movements.
I can only imagine the challenges involved in building a robust network for a drone swarm.
Oh, absolutely.
Yeah.
We're dealing with potential transmission failures,
Right.
delays, fading signals,
Yeah.
message errors, you name it.
Wow.
And remember, these drones are often operating in unpredictable environments.
Yeah.
Forests, mountains, urban canyons.
Right.
The network has to be incredibly resilient and adaptable.
So standard Wi-Fi probably isn't going to cut it, right?
No, not really.
What kind of technologies are we talking about here?
Well, some swarms do utilize familiar technologies like Wi-Fi or even cellular networks,
Right.
but these have their limitations.
Yeah.
Others are exploring satellite communication for wider coverage.
Okay.
The real innovation, however, lies in alternative networking solutions that can handle the unique demands of a drone swarm.
Like what?
Things like named data networking or information-centric networking.
Wow. Okay.
These approaches move away from traditional models and focus on efficient routing and content delivery, even with irregular connections.
So we're making the network itself Smarter and more responsive to the needs of the swarm.
That's precisely it.
Wow.
And this ties in directly with the computational side of things.
Okay.
Each drone is equipped with an onboard computer,
Okay.
essentially its own mini brain,
Gotcha.
to handle data processing, decision-making, and controlling the drone's actions.
So each drone is like a mini pilot.
In a way, yes.
Wow.
These onboard computers run microservices,
Okay.
specialized programs for tasks like sensing. So
Decision-making and responding to changes in the environment.
it's amazing how much complexity is packed into these small machines.
It is.
Yeah.
It's a testament to how far robotics and computing have come.
Absolutely. And what's even more impressive is how the networking and computational systems work together.
That's right.
Right.
Amplifying each other's performance.
Can you give us an example of how they support each other?
Sure. So the network topology,
Right.
the way the drones are connected impacts how quickly and efficiently they can exchange data.
Okay.
This directly affects computational tasks, especially those needing real-time information.
Got it.
For instance, if a swarm is mapping a wildfire,
Okay.
a well-designed network allows the drones to share data about fire boundaries and safe pathways much faster,
Okay.
making the entire swarm more efficient and safer.
So a smart network can make the drones think faster and react more quickly.
Yes,
What about the other way around?
Yeah.
Can computing enhance the network?
definitely.
The computational system can analyze environmental data,
Okay.
like changes in altitude or terrain features to optimize network performance.
Okay.
Think of drones flying through a mountainous region.
Right.
The drones can use their onboard computers to model the terrain and predict the best communication pathways,
Wow.
ensuring they stay connected even in challenging environments.
So the drones are using their mini brains to figure out the best way to talk to each other.
That's right.
Incredible.
It is.
This seamless integration is key for achieving something called self-organization, right?
You're right.
Oh.
Self-organization is where the swarm can adapt and coordinate without needing constant instructions from a central controller.
So they're kind of thinking on their own.
They are.
Wow.
It's like a team of explorers mapping a new territory.
Yeah.
They share information,
Right.
make decisions, and adjust their course as they go
Okay.
without needing constant direction from base camp.
That level of autonomy must be incredibly valuable.
It absolutely is.
Yeah.
Self-organization makes the swarm more scalable,
Right.
robust, and resilient.
Right.
Imagine a swarm inspecting a bridge for structural damage.
Okay.
If one drone malfunctions or loses connection,
Right.
the others can seamlessly adapt and continue the mission without missing a beat.
Wow, that's incredible.
This seamless integration of networking and computing makes this level of autonomy possible.
So we've talked about networking and computing being essential for self-organization.
Huh?
But what are the specific algorithms
Right.
that give these swarms their intelligence?
That's where swarm intelligence algorithms come in.
Okay.
These algorithms take inspiration from biological systems.
Got it.
And colonies be colonies, flocks of birds.
Okay.
They mimic how these natural swarms achieve complex group behaviors.
That's amazing.
Yeah.
What are some examples of these algorithms, and how do they work in the context of drone swarms?
Well, there are two main categories we need to explore:
Got it.
optimization and consensus.
Okay, optimization sounds like it's about finding the best solution to a problem.
It is.
What kinds of problems are we talking about here?
Think of tasks like path planning, obstacle avoidance, and target searching. In a disaster zone, for example.
Right.
A drone swarm might need to find the most efficient route to deliver medical supplies
Okay.
while avoiding dangerous areas.
Right.
That's where optimization algorithms shine.
Okay.
Some of the most popular ones include particle swarm optimization, or PSO,
Okay.
ant colony optimization, or ACO,
ACO.
and bee colony optimization, or BCO,
Okay.
each drawing inspiration from nature's problem-solving strategies.
Those names definitely sound nature-inspired.
They do.
Can you break down how one of these algorithms actually works in a drone swarm?
Sure, take ACO, for instance.
Okay. ACO.
Imagine a swarm of drones navigating a dense urban environment.
Okay.
Each drone acts like an ant,
Got it.
leaving a digital pheromone trail as it explores,
Yeah.
as more drones explore. The most efficient and safe routes become more visible,
Okay.
allowing the swarm to navigate complex obstacles
Right.
like buildings or power lines with minimal collisions.
So they're creating like a dynamic map
That's right.
of the safest and most efficient paths as they go.
They are.
And what about consensus algorithms?
Yeah.
What role do they play in drone swarm intelligence?
Consensus is all about agreement, ensuring all the drones in a swarm agree on a common course of action,
Right.
even with communication limitations or conflicting data.
Got it.
Think of a group of people trying to make a decision.
Yeah.
They might have different opinions and information,
Uh-huh.
but they need to come to a consensus to move forward effectively.
So how do these consensus algorithms work in practice?
Two prominent examples are Paxos and Raft.
Paxos and Raft.
Paxos is like a sophisticated voting system,
Interesting.
guaranteeing that even if some drones fail or messages get lost,
Right.
the swarm will still reach a consistent decision.
That's important.
It's a remarkably robust way to ensure the swarm stays unified even in challenging circumstances.
So it's like a democratic process,
Exactly.
but designed for drones.
That's right.
And Raft, well, a bit simpler than Paxos,
Yeah.
is also very effective at achieving consensus.
It is.
Okay.